If while you're taking measurements you get a message that the PDOP is bad, you're going to have to wait until the PDOP improves. The PDOP is the precision dilution of position, and it tells you how good your measurement is in position. It generally means that when the PDOP is bad, the satellites are all clustered in one portion of the sky, and so your ability to get a good position is limited. When the PDOP drops to a lower value, that means the satellites have spread out in the sky and you get a much better position location. When you're working in the built-up environment, such as on the streets of a city, you can have problems with getting an accurate position. The reason for this is the tall buildings will actually block the signal from the satellite. You can also have something called multipathing, where the signal from the satellite bounces between the buildings. This can also happen when you're working out in the wilderness. For example, if you have tall mountains in the area blocking the horizon, or if you're in a deep valley or even a canyon, that will block much of the signal from many of the satellites. Here Mpofana is helping us demonstrate the assembly of the rover differential GPS. First we take the two poles and screw them together. Here he's taking the sensor out and he's attaching the antenna that connects the rover to the base station. Now he's putting on the pole, he's attaching that to the GPS antenna. You must be careful not to cross-thread the screws, as that can damage the antenna. He needs to attach a bracket to the pole at a comfortable height that will hold the controller. It's important that this bracket be attached tightly in order to keep the controller steady. The controller slips inside the other side of the bracket and must be fit snugly into the bracket. Don't turn the screw too tight or you could damage the controller. Once everything is connected, you can turn on the antenna. Here he's checking to make sure the lights on the antenna have turned on and it's connecting to the base station. First you take out the stylus and turn the controller on, and then you can go through the various menus and pick out the parameters that you need. You can input the farm names or the station names of the various positions that you're going to collect. You can also tell it to average a number of collection points. Be sure to carefully put the stylus back, because if you leave it hanging out, it can snag on twigs and thorns. Be sure to close the case before you leave and put it in a secure place. Now you're ready to do your survey. One of the most common applications of differential GPS in geophysics is collecting data points that have already been collected by another method. So in this case, we go to a position where we've left a peg or a marker behind, and we need to take that position accurately. Here Mpofana is measuring a position that was previously collected using another instrument, such as a gravity meter. He then takes the position and then moves off looking for the next peg. Another common application of differential GPS in geophysics is to return to a position after some time. So for example, the following year you might want to go to the same position. In this case, there won't be any marker, and you have to upload the coordinates to the differential GPS. Here Mpofana is looking for that position. He has to move the differential GPS around a little bit to make sure he's on exactly the right point. Then he can record that point again before he moves off and looks for the next position.